Okay, so we're going to be starting chapter 5 now, and chapter 5 is a different kind of way of looking at trig functions than we have yet. What we're really doing is proving trig identities. So this trig identities paper is something you want to have out the whole time. This is going to be something that you need every single day. So these identities we're going to be using, and some of them, as we learn newer and newer identities, we're going to be proving these identities are true. Now, proving identities is different than solving. We cannot add, subtract, multiply, or divide anything on each side of the equation. We can't square root each side of the equation. We can't square both sides of the equation. We can't do any of those things. The only thing we can really do is substitute and simplify. Now, verifying an identity is just confirming that it is in fact true. So the only way to get credit for this is to show every single step. There is no single answer at the end. There's no number or anything like that. Your answer is the process you're showing of proving that both sides are in fact equal. So let's look at our first example here. Verifying this identity. It says cosecant x times tangent x equals secant x. So what we're going to do is we're only going to work on one side of the equation, and secant I can replace with 1 over sine x, and tangent I can replace with sine x over cosine x. And we can see here that these will cancel out, and I'm left with 1 over cosine x, and then secant x. And so we've proved that this identity is in fact true. So it's important to show every single step of simplification here. And there's one thing that we'll write at the end of our proofs. So at the end of this proof, we're going to write QED. Now this is abbreviated for a Latin phrase. That Latin phrase is quod erat demonstratum. And basically what that means is what I set out to prove, I proved. Okay, so we're going to write that at the end of our proofs just to show, yes, we did get to the very end. We proved what the identity was asking us to prove. Okay, so let's look at our next example here. We have cosine x plus cotangent x plus sine x equals cosecant x. So I'm going to continue using my identities. Cosine x, I'll just write over 1. Cotangent is cosine x over sine x, and then plus sine x. And again, I'm only working on one side of the equation, and I'm just using my identities to see if I can make this side look like that side. Well, now I have cosine squared x over sine x plus sine x equals cosecant x, and we're still not there yet. But what I can do is I can multiply by something on top and bottom. Well, I want to try and create a common denominator. Now, I'm not multiplying both sides by anything. I'm just multiplying by 1 right here. So I'm only doing things on one side. I have not added or subtracted anything. I'm just multiplying by 1, or sine over sine. And now we have a common denominator, and I can add these things together. And again, every step is so important. You cannot skip steps here. So this right here, using my Pythagorean identities, cosine squared plus sine squared is equal to 1. So I can replace that with 1 over sine x, and that is cosecant. Okay. Now, sometimes what you might see is textbooks, and I think your book does this, we'll just put like a little square filled in right there. That means the same thing as QED. I personally like QED, but you can do that if you'd like. And so this is what we're looking at here. This whole thing is my answer. It's not just this last line that's my answer. I should see this whole process out for each of these questions. Let's move on to our next example. We have cosine x plus cotangent, sine x plus sine x minus cosine squared x equals sine cubed x. Well, first off, we can factor out a sine x. And then looking at this, I can use my Pythagorean identity again. And 1 minus cosine x is equal to sine squared x. And again, it's important to show this step here, showing what you're substituting, and then this is sine cubed x. Okay. Looking at our next example, we have 1 plus cosine x over sine x equals cosecant x plus cotangent x. Now something like this, it's hard to know which side to work on. So I'm going to do it working on this side first. And then I'm going to do it another way working on this side first. So I can separate these fractions. I can have 1 over sine x plus cosine x over sine x. And this is cosecant x. And cotangent x. And that's exactly what we wanted. Okay. Now, what if I didn't think about that? What if I thought, you know what, let's work on the other side. So let's say I work on this side instead. So cosecant is 1 over sine x, and cotangent is cosine x over sine x, and then that would be 1 plus cosine x over sine x. And that's the same thing. So I can work on this side or I can work on this side, but I can't work on both. Okay. Let's look at the next one. So here we have sine x over 1 plus cosine x. Now I can't split that up, but this I could split up if I wanted to. And so we need to kind of look at the different options here. So the first thing I'm going to do is I'm actually going to try and come up with a common denominator. So I'm going to multiply, let's see, I'll just copy this first. And then I'm going to multiply by 1 plus cosine x, 1 plus cosine x. And then I can multiply by sine x over sine x. And now I have sine squared x over sine x times 1 plus cosine x. Plus, if I FOIL this out, I have 1 plus 2 cosine x plus cosine squared x over sine x, 1 plus cosine x. And I've still just been using that common denominator. And now that I have a common denominator, I can group things together. So I have sine squared x plus, and I'm going to reorder these things so we can see something happen here. And we know that this right here is equal to 1 from those Pythagorean identities. So I have 1 plus 1 is 2 plus 2 cosine x over sine x plus cosine x. Oops, plus times 1. There we go. And I can factor out that 2. And I have 1 plus cosine x over sine times 1 plus cosine x. And those cancel out. And I have 2 times 1 over sine x. And that's 2 times cosecant x. And that's the end of my proof. Now, I did it this way, but I already can see other options here. I could have multiplied this fraction by 1 minus cosine, and then multiply this one by sine over sine, and use the Pythagorean identity in that way. There's so many different options of different things you could do. But I need to be able to follow every single step here. Much like when we worked with matrices, where I need to be able to read every single step and show me every single step, the same way with these verifying identities. So we've just proved that this is equal to that. Let's move on to our next example. So here we have cosine over 1 plus sine x equals 1 minus sine x over cosine x. Now, normally when I have students look at this problem for the first time, what they want to do is cross multiply. You can't do that. You cannot cross multiply here. We're not solving anything, so that's not one of our options. What we can do is we can pick a side to work on and then try to work it out from that. So I'm going to choose one side to work on, and I'm actually going to do this 2 different ways for you. So see 2 different ways of doing the same problem. Now I'm going to choose first to work on this side. Let's work on this side first. So I have cosine x over 1 plus sine x, and I'm going to multiply by the conjugate of the denominator. So 1 minus sine x, 1 minus sine x. And those cancel out, and I have sine cosine x times 1 minus sine x over 1 minus sine squared x. And now we have, I can replace this with cosine. And then those can cancel. And we have 1 minus sine x over cosine x as we wished. Well, that's with me working on this side. What if I chose to work on that side? So if I chose to work on the other side, then I would start with 1 minus sine x over cosine. And I'm going to actually multiply by cosine x over cosine x. So then that would be 1 minus sine x times cosine x over cosine squared x. And I can replace this 1 minus sine x with 1 minus sine squared x. And this is a difference of perfect squares. I can rewrite that as 1 plus sine x, 1 minus sine x, 1 minus sine x, cosine x. And then we see that these cancel, and I have cosine x over 1 plus sine x. And that's what we were looking for. So we've seen now 2 different ways to do the same problem. We have a few more examples left, and I'll go ahead and continue those in part 2 of the video.